So I'd like to introduce a man who uses software to make the web good and not evil. Ladies and gentlemen, Douglas Crockford.
Good morning, everybody. I'm really happy to see all of you equally. So for years I've been spanning the globe talking about the web and the things that are wrong with it, that need to be corrected, and why they need to be corrected, hoping that some organization or laboratory or company or university or anybody would fix it. That didn't work. That didn't happen. So I'm going to fix it. So let me give you a progress report on what I've been working on, the Seif Project. So it starts with the web. You all know about the web. The web has become the most important application delivery system the world has ever seen. The reach and capability of the thing is absolutely amazing, but it comes at a cost, right? It doesn't quite work right. And from my perspective, the things that are worst about the web are the problems with security. That more and more of what we do is in the web, and the web was not designed to do all the things what we're trying to do, and as a consequence, it tends to undermine us, and it tends to compromise us and create problems for all of us. So one of the problems with security in the web is its reliance on passwords. We have a lot of history with passwords in computing. The very first computers did not have passwords. They relied on physical security. There were men with guns who were protecting those machines, and that worked. That worked really well. It worked until disk drives were invented, when we had online storage, and then when time sharing becomes an important way of sharing computers. So a time-sharing company would buy a big mainframe, and they would allow people all over the country to connect to it through terminals. And they needed to make sure that the people connecting to it could not get access to other customers' data, and they also needed to make sure that nobody could connect to them without paying for the time that they used. We used to charge people for computer time. So they used passwords, and passwords worked, because there was only one person, or each person would likely only have one time-sharing account. People can reliably remember one password, so that worked. When PCs start up, we completely forget all of that, and we go back to no passwords and physical security, and that works until we start distributing floppy disks around, and so now we've got floppy-borne viruses. And it gets really bad when we start adding disk drives and networking to the PCs. Now suddenly everything is awful. So passwords come back in again. Your PC has a password. Then the web starts. And again, the web forgets all of that history. And so initially, there are no passwords on the web. And then the first site that needs it says, OK, we'll have a password because we've got stuff and we need to protect our customers and our data. And the second site that needs to do that says, well, they used passwords, that'll work for us too. And pretty soon, every site has a password. And now you're talking to dozens, maybe hundreds of sites, and each one should have a separate password. Humans cannot manage that, but that's the state of the web. So the first time we see the word password connected to the web is in RFC 1738. And it includes a format for a URL that contains a username and a password, and this gets sent in the clear. Now, at least one of the authors of this RFC recognized that this was a really bad idea. And so he includes the sentence, "The use of URLs containing passwords that should be secret is clearly unwise," which is an amazing bit of understatement. But they didn't have anything better to recommend, so this went out, and there were people who used it, and they very quickly found out why it was unwise. So I'm going to be talking about what's wrong with the web, because we have to look hard at what's wrong with the web if we're going to fix it, because if we don't understand why it's wrong, then our corrections probably won't make sense. And this is going to be shocking and upsetting to many of you, that you have worked your whole careers, your whole lives with the web. You don't know anything else. You rely on it for your livelihood. Many of you define yourselves as being of the web, and I'm going to tell you all that's wrong with it. I'm not talking about you, okay? This isn't about you. This is about the web and what we have to, the process we have to go through in order to make the web better. So there are a lot of things that are wrong with the web, but I'm primarily focused on its insecurity. And much of its insecurity is a consequence of its complexity. That the web started off as an amazingly simple thing, but we added a whole lot of new stuff to it, and we can't stop it. The standards processes are out of control. We're always adding new stuff, and the consequence of adding the new stuff is the thing gets really complex. And complex systems are really difficult to reason about, particularly the security of complex systems, virtually impossible to reason about, and that's why our systems are insecure. So let's go through some of the components of the web. First, there is HTTP, the Hypertext Transport Protocol. It's a request-response protocol that was designed for retrieving documents, and as a document retrieval protocol, it's probably not too bad. You can look at it as being three specific things, all kind of mushed together. The first is it's a data format for key-value pairs. It's a fussy, kind of eccentric format. I think there are much better key-value pair formats in the world than that. It's a negotiation protocol. So the early web browsers were not competent about all of the graphic formats and other kinds of resources, and so there'd be a dialogue. You know, I need this, well, I don't know how to do that, but I got that. Can you do that compressed, and so on. They'd trade things back and forth. Not so important now. The browsers have all caught up, and they're all pretty competent. They can handle anything you can send them, but that negotiation protocol is still there, and it's expensive. Then it's a request-response protocol. You request something, you wait, then something comes back, you display it, probably you'll disconnect and then go to something else, wait for it to come back. And that made sense in the very beginning of the web, but that's not how we use the web today. You'll load a page, and that page will contain hundreds of additional assets, images, scripts, styles, all kinds of stuff. And for each one, you then have to go out to that server again and go, wait for the next one. Then you can ask for the next piece, wait. That's hugely inefficient. So one of the ways we mitigate that is we'll have the browser open several connections to the same server so that it can get some interleaving going on, which adds a whole nother level of complexity. There's DNS, the domain name system. This was a well-intentioned thing to make it easier for people to get to a computer without knowing its IP address. That instead, you'll type in a simpler name, and the world will look it up in a database somewhere and direct you to the right machine. This has some problems. One is it is not compatible with the trademark system, but we use domain names like trademarks, and because those are not compatible, we find there are all sorts of complexities and a lot of legal wrangling and a lot of stuff which will probably never be solved. Worse than that, there are security problems inherent in DNS. There are DNS poisoning attacks and other confusion attacks, squatting and all of that, which seem to be inherent in the system. There's SSL, secure socket layers. This was developed at Netscape because they correctly recognized that we needed some form of link encryption and authentication in order to do electronic commerce. Unfortunately, SSL is a very complicated protocol. It's very efficient, and because of its complexity, it has terrible security problems. We are still finding tremendous security problems almost every month in SSL. It's been 20 years. We've had this thing for 20 years, and we have not converged on correctness yet. One of the sources of complexity in SSL is its reliance on certificate authorities. So the thing which will associate a domain name with another name is a certificate. certificates come from organizations like VeriSign. But if you have a certificate from VeriSign, the only thing you can really be sure of is that somebody gave some money to VeriSign. It's not clear that the certificate actually tells you anything more than that. And do I trust VeriSign? I don't know who they are. Why should I trust them? I don't know. I don't know who they are. I do know from reading Wikipedia that they have been hacked and that they still are not forthcoming about what the hackage was or what was compromised or what. So should I trust them? I don't like trusting anybody. And I think I've got reasons for not wanting to trust VeriSign. But worse than that, there are hundreds of other certificate authorities, and your browser trusts them all equally, and many of them have already been compromised. We have seen this stuff, and I don't like that. I want a system where I can have confidence in it. HTML, the hypertext markup language. Is HTML a good thing or a bad thing? Well, it depends on what you want to do. If what you want to do is to mark up simple documents, simple technical documents, that's the thing that HTML was designed to do, it's really awful. It's complicated, it's fussy, it's ugly, it's nasty. It is why we invented markdown languages. Markdown languages do a much better job at marking up simple documents than HTML does. Now, if what you want to do instead is to deliver interactive applications to the world, it's really terrible because it wasn't designed to do that at all, and it just does a really bad job of it. One of the things I like least about HTML is that it almost requires use of templating. In templating, you've got some HTML with some variable holes in it, which will get plugged in with stuff, and that's how we build applications. I don't like templating because it is the major vector of XSS injection, so it's got inherent security problems. It is possible to do templating correctly, but apparently that never happens because we still hear about new XSS attacks all the time. It's just too difficult to get this stuff right. I also don't like it because it creates this dependence on HTML that gets into every level of everything. And so everything that's happening in the browser is all about generating HTML. Everything that's happening in the server is all about HTML. Going all the way back to the database, everything all wants to be about HTML. And it's really a brittle thing. I mean, it's gotten so bad that we're now looking at doing client-side templating, which is nuts. You know, we're doing it all over. Then the third thing I don't like about templating is a trap. Because if we've got everything is dedicated to HTML generation, that means we're never going to get free of it. We're going to be messing with HTML forever. There's the DOM. The DOM is the document object model. It is the API that the browser presents to JavaScript. It may be the worst API ever imagined. It's just awful. It's brittle, it's clumsy, it's at the wrong level of abstraction, it's not portable enough, it's wildly insecure, it's just awful. When you talk to web developers who say they hate JavaScript, what they're really hating is the DOM. They just don't know what the difference, where the boundary is. CSS, crappy style sheets. CSS was developed for formatting of documents. And since then, we have extended it several times in order to give it additional capabilities. But it's really complicated. The style sheets that you develop tend to get really complicated. They tend to grow over time, and you can't squish them down. It's unreliable in that one style rule can affect things which appear to be unrelated, so it's very fragile. Then there's JavaScript. JavaScript is a hot mess. JavaScript was designed and implemented in 10 days, which was an amazing accomplishment. But it turns out you can make a lot of mistakes in 10 days. And those mistakes are in JavaScript and will always probably be there. Standards can add new features to the language, and sometimes the features are good, Sometimes they're not. We just keep growing it. But the good news is that there are good parts in this language. There's actually brilliance in this language. And if you're working with those good parts, programming gets easier and the programs become more reliable. And when things are simple and reliable, it's more likely they're going to be secure. So there's some goodness in this language, and so I want to keep with this part. So I'm not the first to have recognized that there are all these problems with the web. There are many before me who recognize that there must be a business opportunity here because the web is so damaged in so many ways. There's got to be a way to replace it with something better, and we can make money off of that. So Microsoft, Adobe, Apple, Oracle, and many other companies, large and small, have all gone after the web. In most cases, the technology that they offered was much better. In most cases, what they offered was not open, that what they were trying to do was to capture the web or displace the web, to own the web, basically, or to own its successor. And so that makes me glad that they all failed. Because the thing I like the best about the web, the reason why I want the web to survive and to continue to flourish and grow, is because of its openness. That with the web, if you have an idea and you want to present it to the world, you can do that. And you don't need to make a deal to anybody. You do not have to submit to anybody. You don't have to share your stuff with anybody you don't want to share it with. It's open to anyone who wants to do that stuff, and I think that's great. And the web is the only global platform that can do that. And that's why I love the web. And I think the reason these other attempts at capturing the web failed wasn't because they were closed. It was because they didn't have an adequate transition plan. How do you get from A to B? And who do you have to move from A to B? In all cases, what they thought they needed to do was to move you. If they could convince enough developers to move to their platforms, they win. And that turned out not to be the thing. So it's a different thing. So what I want to do is to upgrade the web. I want to keep it doing the things it does well. In fact, the web does some things very well, and I want to leave that alone. I don't want to touch it. I don't want to make it more complicated or harder. It stays exactly the way it is. But the stuff that we need to do, which needs to be secure, which is important, I want to provide a better way within the web for accomplishing that. And I want to provide a transition plan which gets us all there. And my metaphor for the transition is HDTV, high-definition television. So it wasn't very long ago, broadcasting in this country was analog, using a system called NTSC. And the consumer electronics industry decided that they wanted to have a new television system because that would allow them to sell a lot more new television sets. And that would provide growth and jobs and all of that. And the government thought that's a good thing too, because all that growth and jobs and new stuff means more taxes, and that's all good too. So everybody got all excited about designing this new system. The FCC granted new spectrum to the broadcasters so that in addition to doing their analog broadcasting, they could also simultaneously be doing digital broadcasting, with the expectation that eventually they will take all of the analog spectrum away from the broadcasters and relicense it for new applications, maybe internet or public service or other things, which much of that might mean more money for the government, and the government was really keen on that. But there was a concern that if the transition didn't go properly, that if they said on some day and date, on January 1st of some year, we turn off all of the analog transmitters, and everything is all digital now. So if you haven't made the transition, your TV is going to go dark. And then the Super Bowl happens, and everybody misses it, and then there is armed rebellion. The government was really concerned that that could happen, and so they came up with a transition plan so that that wouldn't happen. And in fact, it didn't happen. And the transition plan was based on a thing called the set-top box. Now, the old timers might remember televisions used to be in great big rectangular cube boxes that were so big that you could set another box on top of it. And that other box could do things which would then affect what you saw on the television set. And one of the set-top boxes, so there were lots of set-top boxes. There were some that would connect to your cable system or your satellite system, or you could have your videotape system or your game system. And there was also a high-definition set-top box, which would allow you to receive a high-definition TV signal, and it would go through your box and then get fed into your analog TV so you could watch the new shows. And the government provided these set-top boxes to anybody who needed one for low cost or no cost. And it worked. And so we switched off all of the analog, and we're all now on digital, and it worked. So I'm proposing that we do something similar for the web. That what happened was they didn't try to make the transition easy for the broadcasters. In fact, it was really hard for the broadcasters. The broadcasters had to buy digital transmitters, and they had to operate them and all of the analog stuff, and it didn't create any new revenue. That they had lots of new operating costs and no revenue to compensate for that. They didn't make it easier for the producers of programming, because the programmers had to now go and buy better cameras and better equipment for making their shows. They had to make their sets better. They had to make the costume and makeup. Everything had to get better, and there was no new revenue to pay for that. The people they made the transition work for were the viewers. They wanted to make sure that the audience would be able to move into the new system as painlessly as possible, and that worked. So if you had one of those set-top boxes, you didn't even know if something was a digital channel or an analog channel. You might notice that the digital channels look a little better, and you might have noticed that switching between digital channels seems to take longer for no good reason, but it does. But otherwise, it was a completely smooth transition. And I want to do that for the web. But for the web, instead of having a set-top box, I propose a helper app. Helper app is a component of browsers. The first web browsers did not know how to display all of the image types. They didn't know how to play sounds. There were a lot of things they couldn't do. So if you asked a browser to do something that it didn't know how to do yet, you could have it start some other program that did know how to do that. So if you tried to display a ping file and your browser didn't know about pings, it could open a paint program, and maybe the paint program knows how to display the ping. So it's weird and annoying, but it worked. And it turns out that interface is still built in all the browsers, and I think we can take advantage of that. So the new capabilities that I'm talking about, the simpler, more secure way of developing applications using JavaScript, we can put that stuff into a helper app, and anytime someone tries to access one of these new applications, the helper app will run, and that will allow us to take advantage of the new goodness. Now, the problem with the helper app idea is that this time, there's no way we can convince the audience to get one. I think I could convince most of you to install a helper app if what we're talking about is really interesting, but the rest of the audience isn't going to do that. So the transition is going to depend on us being able to convince the browser makers. So here is my transition plan. Step one, I need to convince one progressive browser maker to integrate the helper app so that it's built into the browser so that when you try to do this thing, instead of running a separate program, instead it just opens up a tab and it looks like it's in the browser, but it's just this new stuff. This should be an easy thing to do because all we require is a rectangle that we can put some pixels in, access to UI events, and a JSON channel between the new thing and the old thing. It should be easy to do. Who does it? I don't know or care. My expectation is it'll probably be Mozilla, because they used to be a leader in web technology, and they've sort of lost that initiative. They might want to get it back. This might be a way for them to do that. Microsoft, same story. They used to be a leader in web technology, and they've fallen way behind. They've done some amazing work in Edge. I think Edge is really impressive, and it seems that nobody cares. But this might be a chance for them to get you to take another look at them. Step 2, I need to convince one secure site to require its customers to use that browser. It could be a medical site or a financial site, somebody who has a real need for security and who is scared to death of having to operate in the current web, which they're doing because of competitive pressure, but they're really afraid of what is about to happen. They're constantly in this state of fear. And so they may elect to say, okay, for at least one service that we provide, you have to use this new browser with this new safe capability built into it in order to access us. I'm pretty confident we're going to find somebody to do that. Then risk mitigation will compel all of the other sites that have similar concerns to do the same thing. Once the first one has demonstrated that this is safe, then I think many more will follow because they need that safety. It's similar to what happens to penguins. So, penguins are standing on the edge of the ice floe, and, they're looking down the water, and they're hungry because they've been on the ice for months, and there are fish down in the water, and they really want to get down and eat that fish. But they also know there are leopard seals and sharks and other things down in the water that eat penguins. And so they're just looking there really carefully, trying to see if it's safe, and they keep pushing each other, and closer, and eventually one of them falls in. And then everyone else looks. And if he comes back up, they all go in. So I'm hoping we can do a similar thing like that. Then competitive pressure should move the other browser makers to do this too. No one will want to be the last browser to be able to do this. And since integration is real easy, that they should all want to do it once there's demonstrated that there is demand for it. And then I expect the world will follow for the improved security and faster application development. I don't expect everything moves. In fact, everything doesn't have to. If there's stuff which works just fine in the web the way it is, which doesn't have these reliability or security concerns, it can stay exactly the way it is. I'm not proposing to obsolete anything ever. I'm just providing a new way of doing stuff which is important. And nothing breaks. We're not going to invalidate anything. We're not going to close anything. We're not going to capture anything. Everything remains open. Everything just gets better. So the system I'm proposing is going to have some strong cryptography in it. We're going to be using elliptic curve 521 for key exchange and authentication. We're going to be using AES 256 for link encryption and SHA-3 256 for hashing. These are probably all stronger than I need, but I want to be using these because I'm paranoid, and I want to have that. Now, having strong cryptography in a system is no guarantee that it's going to be a secure system. In fact, we've seen lots of cases of systems claiming to have strong cryptography who got broken because there are lots of other things you need to attend to as well. But we're going to start with that. There's a guy named Zooko who has a theory of naming. He says that any name can have one of 3 desirable properties. The web chose human meaningful, at least to the extent where you think a URL is human meaningful. But I'm more concerned about security, so I'm going to be taking the other 2. I'm going to be making names which are securely unique and also globally decentralized. So there'll be no central authority issuing names. Anybody can create a name and be confident that it's going to be secure. So the way we're going to do that is we're going to be using elliptic curve 521 public keys as unique identifiers. And you don't go to anybody to get one, you make one yourself, and it'll be generated randomly. And because it's such a huge number, you take one of these in base 32 encoding, it's 105 digits long. That's That's huge. And if we generate them correctly, they're virtually unique, and that'll work. And that will become the basis for how we authenticate in the system. So having that, we're going to be doing secure JSON over TCP instead of HTTP. JSON, I think, is a much nicer format for expressing the envelopes that we're going to be sending the data in. We'll also be providing support for blobs. So if you have some big thing which isn't easily expressed in JSON, just say this is a big hunk of bits, and we'll send that as well. And it'll all be link encrypted and secure and reliable. So this is a safe URL. This is a URL that we'll use for transiting from the old web to the new web. This is a really ugly URL. It contains stuff in it that you don't normally see in URLs, although you can. So it'll contain our public key, which is, again, 105 digits long. I don't expect people will ever type these in. These are things that machines will generate and machines will consume. But I want to put the public key in here because I don't trust VeriSign to provide me the public key. Right? I'll trust whoever gives me this URL. I think they're more trustworthy. And then we'll get the IP address, which in IP6 is also a huge thing. So I don't expect anyone is going to type these in, but it is possible. So I want to make it at least possible so that, the resistance, when things are going really bad, you type in 200 characters and you can connect, It's going to be really hard, but if you're motivated, you can do it. But it also means there are no passwords in the system. And that means there's no way someone can torture you and say, give up your password, because there's no way you can recite a 105-digit number in distress. I don't think you could do it even if you were relaxed. It's just not something humans could do. You can't possibly give it up. And then we can also provide a referral code at the end. So where do you get these? So I don't trust VeriSign, I don't trust DNS, which is why I hard code these things in the URL. But I would trust Google, right? If I'm trying to get to a site and I ask Google, how do I get to the site? And if Google returns one of these, I'll trust it. I think they're good. Another way we could use these is I could go to my bank, and my banker could give me a card with a QR code on it, which contains this stuff, and the referral code will be a capability that will connect to my account. So if I scan that with any of my devices, then that will connect me to the bank. I'll never have a password with the bank. I don't even need an account number with the bank. I'm just connected. We'll also provide a trust management system, so all of the relationships that we create in the Seif system, we can keep them out in the cloud, but properly secured, and so you can get access to that stuff through all of your devices. We'll also provide a pet name system. Since you can't recognize 105-character anything, we'll allow you to assign your own names to these things, and so by using those names, you'll have confidence that you're getting to the right thing. Our model of computation relies on a container that we call a vat. A vat is like a sandbox, except it doesn't leak. I have a cat, so I can tell you when the sandbox leaks, that's a bad thing. But a vat is a good thing. So nothing can get in and or out of the vat except through JSON messages. And so we can be confident that we can take any bit of code and put it in a vat and allow it to compute in there, but it can't cause any damage. All it can do is communicate with things which are expecting it to communicate. So this provides us a computational model in which we can have cooperation under mutual suspicion, which allows us to have multiple entities, multiple interests, all running at the same time for your benefit. So you can have one representing a merchant and another representing delivery and another representing payment and another insurance, and they can all be representing different companies, and they can all be working together, but none of them have to trust each other. None of them have to worry about the other one corrupting its environment or getting over on it, which is something we've always been wanting to do in the web. That's why mashups became interesting, but it was never safe. With this system, I think we can make it safe. So this is my plan. So step one is seifnode. Seifnode is a module that you can run on any node server which provides some cryptographic services. It will give you everything that I've talked about. It will also give you some very nice random services. Because we're generating globally unique public keys, we need very good sources of randomness. And so in order to generate good random numbers, we need to have good entropy. And so seifnode will go to the operating system. Operating systems provide entropy services, but I don't trust them to be good enough, so we augment those with your microphone. So we'll turn your microphone on for a few seconds and just get noise from it, and we'll use that noise to help harvest entropy. We'll do the same thing with your camera. We'll turn your camera on for a few frames, collect noise from that, and that will give us enough entropy. We'll then store that entropy away, so we only have to do that once during installation, and we'll be good from that time on. And that's available now. It's on GitHub. You can get to it through that silly URL, and it's there, and it's free, and all of that stuff. I think it's an MIT license. So if this is of use to you, that's great. If you want to look at it and tell us how we got it wrong and how we can make it better, that would be great too. Everything that I'm about to discuss, we're going to do the whole thing in the open. Step two, which we're working on now, is the Seif protocol. This is secure JSON over TCP. It is an efficient session protocol. It's not a document retrieval protocol. It's not an ask, wait thing. It's just send messages and messages coming back. So it allows for push and allows for interactive. It allows for N-way. It's a very flexible protocol. And again, it's all safe and it's all JSON, so it's really nice. Step three will be safe resource management. So that will allow for accessing resources based on their cryptographic hash. If you want to get at an image or a script or some other asset, instead of giving it a file name or a locator, you give it the public key, or the hash of the thing that you want to retrieve. And that way we can guarantee that we will retrieve exactly the thing that you asked for, that you're not going to get something else, that it hasn't been modified in transition or replaced with something else. It also allows for some interesting performance possibilities, because it doesn't matter where you get the thing from. Anything which matches that hash is assumed to be the thing that we asked for, so we don't care where it came from. So that could allow for new sorts of networking services where somebody could maybe have a business out of caching these things. Step four is making the helper app. So we call it Seif Apps. It will be an HTML-free, JavaScript-based application delivery system built on Node and Qt. Qt is an application system that was developed in Norway. It was part of Nokia for a while, but now it's open. It's really nice. It provides a forward way of building graphical applications. It can deal with various device formats and layouts. It's very elegant. But we're going to use it in a slightly unusual way. So we're going to have Node, and we're going to strip Node down, so it's just going to be running the Seif protocol and providing state management and application services, workers, and all that stuff. And then we'll couple it with a Qt system, and we're going to strip Qt down so it's just doing graphics. It's able to talk to GPUs, so you can get very good performance. And it's just going to be doing the interactive stuff, and then there'll be a JSON channel connecting them. So the style of developing applications is you will have an object which you will split into separate presences. And one presence will run in the Qt system, where it will display and interact with the user, and it can send messages to another presence that's running in Node, which is dealing with local state management and business logic. And it's then connected over the network to your server, where there's another presence that deals with the back-end stuff. I think it'll be a very nice programming model. It's going to have some very nice security properties. I think it also compels us to finally partition our applications correctly. One of the problems with the DOM is because everything is happening at the same layer, application architecture gets really confused. And you've got widget-level stuff and application-level stuff all happening in the same mix. And so by putting this stuff into separate servers, there's servers, each running with its own event loop concurrently in separate threads, we're going to get a much better architecture, much higher performance. Then step 5, we take that app framework and turn it into something that we can run in a browser, and then try to convince one or more browser makers to install it as standard equipment. And I'm hoping if they do, that they do it in the simplest, easiest way possible, meaning they don't try to rewrite it or change it significantly, that they just take it, plug it in, and let it run. If we can convince them to do that, that means that a safe application will run in exactly the same way on every server, on every device. How nice would that be? Anybody? Yeah. So the goal of the Seif project is to provide safe and effective relationship management on the web, and not to replace the web, to allow the web to continue to do what it used to do, but allow us another way of doing things which the web does not adequately support. So the old web was great because it provided promiscuity. It meant that you could go and connect to anything, and you're probably going to be okay. You might get shocked and embarrassed, but your machine's not going to get taken over, your identity is not going to get stolen. That hasn't always been true, but pretty much the web can do that. And that's good, because that allows us to get introduced to things. We used to call it surfing, that you could go from one thing to another and discover stuff and start forming relationships. Unfortunately, the same thing which allows the promiscuity to work is very bad for dealing with commitment. So that's what the new web is for. Once I have found my bank, I want to make sure from this point on I'm talking to my bank, and I'm not talking to anything which pretends to be my bank. And there are still forms of confusion and mischief that are possible, but they're not going to be able to do things like steal my bank password and use it against me, because there are no more passwords anymore. All of those sorts of confusion attacks now become useless. And because we're now connecting things, forming relationships, this should work better for connecting people as well. Right now we have to do we do all sorts of terrible things, but we can do safer things now. We can have committed relationships between people as well as between companies. So developing anything which claims to be secure is really hard. You have to ask, does it do what it should? And more importantly, does it not do what it shouldn't? And anytime you make claims about the security of software, it's likely that you're going to be wrong, because software is complicated stuff, and anything with any complexity is difficult to reason about. And so I expect when the safe components, as they're released, come out, I expect they're going to not be safe. But I'm hoping that because of the approach that we're taking, of making it simple, of making it minimal, that eventually we will converge onto something that is. I think that's the only thing that works, because we've tried it the other way and that hasn't. Again, we've had browsers for 20 years and we're still patching them. We should be able to get better than that. So I think because of the extremely minimal approach that we're taking with Seif, I think we'll ultimately get there. So there's nothing new here. There's no new technology, no new discoveries. This is all straightforward stuff. It's using theory, which has been around for decades. It's just a minimal application packaged for the web, inspired by television. So that's the Seif project. If you'd like to know more about Seif, please visit seif.place. Also, safe.space will also work. And that'll just direct you to GitHub where you can see phase 1, phase 2. I'm not giving any dates because I don't have to, so I'm not going to tell you when it's going to be available. So so PayPal has been extremely generous in supporting this work. And one of the best things about the way we're doing this is, while I have in mind a schedule for when this stuff gets done, I haven't told anybody. So as a result, I can't get pinned to anything. So nobody can force me to release something before I think it's ready. And so I'm not going to release anything until it's ready. And I think that's how we should do everything. I really do. But most of us don't get that luxury, but I'm getting this luxury, and so I'm not going to tell you when it's going to be done. But because I have a theory of software, I don't think it's a theory, I think it's actually a fact, that the development of good software takes time, and anything you try to do to make it take less time will make it take more time. And the way we deal with the fact that it didn't get finished properly is that we ship stuff which is not secure. And we've all seen the consequences of that. So I'm going to try to do it the other way. We'll see how that works out. So in the meantime, try that. I'll be back next year, I hope. Until then, thank you and good night.